We will be discussing concepts of system integration and architecture one. So for our discussion today, we will be discussing the following. So what is data and information? What are the different types and classification of information? Characteristics of useful information? What is a system? Characteristics of useful system? Components of an information system? Types and levels of information system, the various phases of system development life cycle or SDLC, software modeling, system design, and UML diagrams. So now let us first define what is data and what is information. So basically data is a given or fact. It could be a number, a statement, or an image. It represents something, quantities, actions, and objects in the real world, and the raw materials in the production of information. While information is defined as data that have meaning within a context, data that has been processed into a form that is meaningful to the recipient and is of real or perceived value in the current or in the prospective actions or decisions of the recipient. So basically, data are considered as raw facts. So example of data are your first name, last name, middle name, your age, your course, your birth date, your address. While information are defined as a processed data. So example of information are students record, employees record, and the like. So information is critical because information is not what we want. Information we have is not the information we need. The information we need is not available. We need information to ensure effective and efficient decision leading to prosperity of the organization. So we have an example of data manipulation in customer survey. So we read data collected from a customer survey with questions in various categories, and it would be time consuming and not very helpful. So when we manipulated, the survey may provide useful information that will be used by the organizations in their decision making. Okay, so we have here different types of information. So the first one is descriptive information. So it answers what is or what is the state of the business, for example. Next, we have diagnostic information. What is wrong or what is a wrong information? This is basically used to standardize or to correct information. Next, we have predictive information. It answers the question, what would happen if? So it pertains to the predictions relevant to decision making. And the last one is prescriptive information. It answers the question, what should be done? So it also means solution or alternative propositions. So basically, the main goal of information is to provide a relevant and objective information or data into the organization. Next, we have information classification. So we have action versus no action. So action is defined as an active information that causes an activity or operation, while no action is information that communicates only when the status is applied without any operation. Next classification is recurring versus non-recurring. Recurring are information that are generated in regular intervals, while non-recurring are non-repetitive in nature. Next, we have internal versus external. Internal data is retrieved from inside company to make decisions for successful operations, while external information are or came from the market, including customers or its competitors. Next, planning information includes or involves establishing goals and arranging them in logical order, while control information are set of procedures and technological measures to ensure secure and efficient operation of information within the organization. And the last classification is the knowledge. These are relevant and objective, which are also used for decision making of top level management. Next, we have here some characteristics of a useful information. So basically, these characteristics will determine if our information is relevant or if it will be useful for the organization. The first one is relevant. So when we talk about relevant, information must pertain to the problem at hand. So example, we have a total number of years of education may not be relevant to a person's qualification for a new job. Relevant information may be that the person has so many years of education in engineering and so many years of experience. So therefore, the information must also be presented in a way that helps a person understand in a specific context. Next, we have the second characteristic, which is complete. So partial information is often worse than no information. Example of which is the marketing data about household incomes may lead to bad decision if not accompanied by vital information on the consumption habits of the targeted population. The next characteristics is very important. So we have accurate. Erroneous information may lead to disastrous decision. So an example of accurate information are students' record. We also have patient record, data or information coming from the payroll or human resource management. So those are some of the example of information that must be accurate. So an inaccurate record of a patient, for example, may lead a doctor to harm the patient. Next characteristic is current. So decisions are often based upon the latest information available. So a short-term investment decision, for example, to purchase a stock today based on yesterday's stock prices may be costly. Mistake if the stock's price have risen in the interim. So meaning what was a fact yesterday may no longer be one today. And the last characteristic is economical. So in a business setting, the cost of obtaining information may be considered as one cost element involved in any decision. An example of which is a demand for a new product may be a research to reduce risk of marketing failure. But if market research is too expensive, the cost of obtaining the information may diminish profit from sales. So again, these are the different characteristics of a useful information. So we have relevant, complete, accurate, current, and economical. So next, let us define what is a system. So a system is a set of components that work together to achieve a common goal. Computer-based information systems take data as raw material, process it, and produce information as output. A system also is a group of interrelated components working together toward a common goal by accepting input and producing output in an organized transformation process. A system also is a functional unit which involves set of procedures, functions to produce certain outputs by processing data, information given as input. So based on the given definitions of a system, we may provide some examples of a system. So for example, for a certain student, we can have an enrollment system which basically includes modules or components such as advising, enlistment, assessment, payment, search, help, maintenance. So those are the different components of an enrollment system. While another example is a library system. So, since a system is a group of interrelated components working together toward a common goal, so in a library system, we also have various components that are interrelated with each other. For example, a library system may have a registration or verification module, a security module wherein the user may be asked to input its username and password or level of access. Next, we also have borrowing, returning, a computation of penalty, and search also for searching books that are needed by the user, whether student or faculty. And we also have reports. So those are some of the example of a system. So basically, the system needs an input, and the data that are inputted into the system will be a process, and the generated output is also very important. So example of its output are the reports needed by the organization. So what are the different components of an information system? So let's proceed with the characteristics first. So we have a system is a whole. Components of a system interact with one another. Systems are goal seeking or it has objective. Systems have input and output. System must be controlled. System forms a hierarchy and systems exhibit differentiation. So a system is considered as a package, which means that it consists of various components, modules, or elements. Say, for example, we have security module. So how are we going to determine what are the different components of a security module? So we have entering unique username and password, and then we have level of access. We have the admin and the second level of access. And we also have forget password, which consists of a secret question or secret answer, or the system will be able to reset the password once the user forgot his or her password. And then the security module also consists of an audit trail, which monitors who enters into the system, who logs in and logs out inside the system. So when we talk about that the system must be controlled, meaning that the system should have its boundary or limitations. When we talk about system forms a hierarchy, so it follows a step-by-step procedure. So now let's proceed with components of an information system. So we have hardware, software, data, networks, procedures, and people or peopleware. So data are considered as the input that the system takes to produce an information, while hardware is a computer and its peripheral equipment such as input, output, and storage devices. And hardware is also considered as the tangible part of an information system. Next, we have software. Software are a set of instructions that tell the computer how to take data in, how to process it, how to display information, and how to store data and information. Next component is telecommunication or networks. So the hardware and software that facilitate fast transmission and reception of text, pictures, sound, and animation in the form of electronic data. Next, we have people or peopleware. So information system professionals and users who analyze organizational information needs. They design it, they construct information system, they write computer programs, they operate the hardware, and they also maintain the software. So next is the procedure. So these are the rules or guidelines for achieving optimal and secure operation in data processing. It also involves priorities in running different applications on the computer and security measures. So, what are the different classifications of an information systems? So, this particular diagram represents the level of management and the type of support systems that are involved inside the information system. So, on top of the pyramid, we have the strategic management, which is responsible for defining the long-term goals of the company and how it intends to position itself within its particular industry. So under the strategic management, we have the executive information systems. Next, we have the tactical management. So decide on budget, set targets, identify trends, and develop short-term plans for the business. And we have the decision support system and management information involved in this particular level of information system. Next, we have operations management, responsible for monitoring the transactions that are occurring and dealing with any problems that may arise. So as you can see in the diagram, the tactical and operation managements involve the DSS or Decision Support System and MIS or Management Information System. And the last level of management is the non-management staff. So attend to routine daily business transactions, example of which is selling goods and issuing receipts for payment. So under this particular level, we have the TPS or the Transaction Processing System. So basically the TPS or Transaction Processing System is also known as OLTPS or Online Transaction Processing System for those systems that can be accessed through web-based. So we have here types of information systems. So let us define what are the different types based on the pyramid that we have discussed a while ago. So the operation level system supports operation managers by keeping track of elementary activities and transactions of the organization. Example of which are sales, receipts, cash deposits, payroll, credit decisions, and the flow of materials inside a factory. So while the management level systems serve the monitoring, controlling, decision making, and administrative activities of middle management. So the principal question addressed by such system is, are things working well? So are the systems or informations are being monitored properly, or the decision making is accurate or fitted with what is needed by the organization. Next, we have the strategic level system, which help the senior management tackle and address strategic issues and long-term trends both in the firm and in the external environment. So external environment means it pertains to your competitors, to the business competitors, or to the customers or clients of the business. Next, we have the TPS or Transaction Processing System. So basic business systems that serve the operational level, a computerized system that performs and records the daily routine transactions necessary to conduct of the business. So example of TPS is or are sales order entry, payroll can also be, and shipping. So basically, TPS allows manager to monitor status of operations and relations with external environment. Next, we have the MIS or the Management Information System. Serve middle management, provide reports on firm's current performance based on data from the transaction processing system. So the data coming from the TPS will be forwarded to the MIS. So it provides answers to routine questions with predefined procedures for answering them. So basically, these levels of management handles past and present data. So example of MIS is sales data, unit product cost data, product change data, or expense data. Next is the decision support system, or also known as DSS. So it serves the middle management, often use external information as well as information from TPS and MIS. So processing is interactive in nature and output in form of decision analysis. Example of DSS is a large stack of inventory where decision support system applications may provide guidance on establishing supply chain movement that works for a particular business. Next, we have the ESS or the Executive Support System. So the ESS or Executive Support System supports senior management or the strategic level inside our pyramid. So address non-routine decisions requiring judgment, evaluation, and insight. Incorporate data about external events, um, such as new tax laws or competitors, as well as summarize information from internal MIS or management information and DSS or decision support system. In this particular type of information system, processing is interactive and output in form of projection. So, what is an example of ESS? So, example is it provides minute-to-minute view of firm's financial performance as measured by working capital, accounts receivable, accounts payable, cash flow, as well as inventory inside the supply chain management system. So, therefore, TPS supports operational level employees. MIS and DSS are for supporting managers, while executive support system supports executives or the top level management. So the relationship of systems to one another is that TPS is the major source of data for other systems, while ESS is the recipient of data from lower level systems. Data may be exchanged between systems, and in reality, most businesses' systems only loosely uh, integrated. Let us discuss SDLC or System Development Life Cycle. So, SDLC is a methodology that also forms the framework for planning and controlling the creation, testing, and delivery of an information system. It also acts as the foundation for multiple different development and delivery methodologies such as the hardware development lifecycle and software development lifecycle. SDLC also is a framework that provides a sequence of activities for system designers and developers to follow. It consists of a set of steps or phases in which each phase of the SDLC uses the results of the previous one. It also aims to produce high quality software that meets or exceeds customer expectation, reaches completion within time, and cost estimates. So SDLC is the application of the standard business practices in building software applications. So it is typically divided into 6 to 8 steps, which consist of planning, requirements. We have design, build, document, test, deploy, and maintenance or maintain. Some project managers will also combine um, split the steps depending on the project scope. So how does the SDLC work? So it simply outlines each task required to put together a software application, and this helps to reduce waste and increase the efficiency of the development process. So monitoring also ensures the project stays on track and continues to be feasible or doable investment for the company. So let us now discuss the different phases of the SDLC. So we have planning, the first one. So since SDLC is a framework, it also applies a sequential approach or a step-by-step procedure in building a software applications. So we will start with the first phase, which is planning, followed by define requirements, design and prototyping, software development, testing, deployment, and operations and maintenance. So let's discuss the initial phase or the first phase. So in this phase, project leaders evaluate the terms of the project. This includes calculating labor and material costs, creating a timetable with target goals, and creating the project's team and leadership structure. So when we talk about calculating labor and material costs, in this phase, we are preparing a CBA or cost benefit analysis, wherein it summarizes the different costs, the software development cost, the hardware cost, the return of investment, as well as the payback period of the system that will be developed. So the timetable pertains to a schedule from the initial phase of the software development up to the last phase. So planning can also include feedback from stakeholders. Stakeholders are anyone who stand to benefit from the application, or they are the users of the system, or the company who will be using the system. So they try to get feedback from potential customers, developers, subject matter experts, and sales representatives. So planning should clearly define the scope and purpose of the application. It plots the course and provisions, the team to effectively create the software. It also sets boundary to help keep the project from expanding or shifting from its original purpose. So this phase determines whether or not the organization has a problem, or whether or not the problem can be solved by launching a system project. Because there are some systems that needs to be enhanced or needs to add improvement inside the system so that it will be more useful to the organization. And some of the system or some of the company uses manual system, which they wanted to try to convert it into a computerized system, or a system that is online or web based. So next step or phase is the define requirements. So defining requirements is considered part of planning to determine what the application is supposed to do and its requirements. So for example, a social media application would require the ability to connect with a friend. So an inventory program might also require a search feature. So requirements are also defining the resources needed to build the project. So for example, a team might develop software to control a custom manufacturing machine, and the machine is a requirement in the process. So in this particular phase of SDLC, we are analyzing the problems of existing systems and define objectives or goals to be attained by a solution, and evaluates various solution alternatives. So next is we have the design or designing and prototyping. So the design phase models the way a software application will work. Some aspect of the design includes architecture. So it specifies the programming language, the industry practices, the overall design, and the use of any templates or boilerplate. The user interface defines the way customers interact with the software and how the software responds to input. So it is also the graphical user interface of your system. Platforms defines the platform on which the software will run. Example, Apple, Android, Windows version, Linux, or even gaming consoles. Next is programming. Not just the programming language, but including methods of solving problems and performing tasks in the application. Next, we have communication. So under communications, we have to define the methods that the application can communicate with other assets, such as central server on other instances of the application. And next we have security, which defines the measure taken to secure the application, which may include SSL traffic encryption, password protection, and secure storage of user credentials. A prototype is like one of the early versions of the software in the iterative software development model. It demonstrates a basic idea of how the application looks and works. So, in this phase, we are pertaining to the logical and physical design specifications of a system. In designing and prototyping of a particular system, we uses various tools such as flowchart. So, I know that you are very much aware of the flowchart or flowcharting technique that are used in the basic programming. So we uses flowchart to demonstrate or to display the logical structure of the system. We also have IP or input process output. We also have data flow diagram or DFD. So those are some of the design tools that can be used under this phase. Next, we have software development. So this is the actual writing of the program. So a small project may be written by a single developer, while a large project may be broken up and worked by several teams, which will perform the rest of the phases of the SDLC. So the coding process also includes many other tasks. So many developers need to brush up on skills or work as a team. So in this phase, finding and fixing errors and glitches is very critical. So tasks often hold up the development process, such as waiting for test results or compiling code so an application can run. And SDLC can anticipate this delay so that developers can be tasked with other duties. In this particular phase, we are translating the design stage into a program code. So the programmer or the development team writes the code based on the required software development tools. So if you are aware of the various programming language to be used for a certain system, so we have various object-oriented programming languages that can be used in developing the system. We also have different scripting languages which can be used for web-based system or online system. So those are the different approaches that can be used in this particular phase of the SDLC. So once we're done with coding the or writing the program, so we will now proceed with testing. So it's critical to test an application before making it available to users. Much of the testing can be automated, like security testing. Other testing can only be done in a specific environment. Consider creating a simulated production environment for complex deployments. So testing should ensure that each function works correctly. So different parts of the application should also be tested to work seamlessly together. Performance tests to produce any hangs or logs in processing. So testing phase helps reduce the number of bugs and glitches that users encounter. So this leads to higher user satisfaction and better usage rate. So basically, when you are conducting your basic programming, so you might be encountering various errors such as syntax errors or logical errors inside the program. So that is a way of testing the software. So in this phase also, the developer or programmer may perform various types of testing, such as, for example, unit testing. We have module testing, integration testing, performance testing, robustness testing, and the like, which are also included under the software engineering course. So next, we have deployment. So in the deployment phase, the application is made available to users. Many companies prefer to automate the deployment phase. This can be as simple as a payment portal and download link on the company website. It could also be downloading an application on a smartphone. So deployment can also be complex. Upgrading a company-wide database to a newly developed application is one example because there are several other systems used by the database. Integrating the upgrade can take more time and effort. So basically, when we talk about deployment, this is the stage where the new system is installed or delivered into the user. So the conversion is complete, and during this phase, the users also review and some technical specialists determine how well it has met its original goals. So in this phase, we are also getting feedback and evaluating the system that has been developed by the development team. So next is the operation and maintenance. So at this point, the development cycle is almost finished. So the application is done and being used in the field. The operation and maintenance phase is still important though. In this phase, users discover bugs that weren't found during testing. So these errors need to be resolved, which can spawn new development cycle. So in addition to bug fixes, models like iterative development plan additional features in future releases. For each new release, a new development cycle can be launched. So during the operations and maintenance, changes in hardware, software, documentation or procedures to production system to correct errors, meet new requirements, or improve processing efficiency are done or performed by the development team. So we can also define maintenance as an ongoing process in the system development. We also perform maintenance in order to correct errors and to upgrade or update the software or systems features. So if, for example, after a month or so of using the system, maybe the users or your beneficiaries or your clients are requested for a new feature like adding new components or adding new elements inside the system. So this can be performed inside the operation and maintenance cycle of the SDLC. So now let's proceed with system modeling. So system modeling is the process of developing abstract model of a system with each model presenting a different view or perspective of that system. So it also helps the analyst to understand the functionality of the system, and models are used to communicate with customers. So models of the existing system are used during requirements engineering. So they help clarify what the existing system does and can be used as a basis for discussing its strength and weaknesses. So then this lead to requirement for the new system. So models of the new system can use during requirements engineering to help explain the proposed requirements to other system stakeholders. Engineers use this model to discuss design proposals and to document the system for implementation. So this particular process is very important in the software development. So we have system perspective. An external perspective where you model the context or environment of the system. So an interaction perspective is where you model the interaction between a system and its environment and between the components of a system. So how one module or one component of the system interact with one another. Say for example, you failed to input a correct username and password. So basically the system will notify the user that he or she entered an invalid password. Next, a structural perspective where you model the organization of a system or the structure of the data that is processed by the system. And the last one is the behavioral perspective where you model the dynamic behavior of the system and how it responds to events. So we have here system design. So under the system design, so we in this phase, we also dealing or um, discussing how your information can be analyzed. by the development team. So it is basically divided into two phases. We have the logical and the physical design. So what are the differences between the two? So the logical design lays out the components of the information system and their relationship to each other as they would appear to user. So basically this is represented by flowcharts or data flow diagram or other design tools that will display or demonstrate the algorithm of the system. The physical design is the process of translating the abstract logical model into a specific technical design for the new system. So basically, it's more on creating a user interfaces for the system. So what are the tools and techniques used for designing? So again, we have flowchart, data flow diagrams, we have data dictionary, structured English, and decision table or decision tree. So let's proceed with UML diagram types. So the first one or the first type of the UML diagram is activity diagram. So it shows the activities involved in a process or in data processing. It's basically a flow chart to represent the flow from one activity to another activity, and the activity can be described as an operation of the system. So the basic purpose of activity diagram is to capture the dynamic behavior of the system, which is known as object-oriented flowchart. So this UML diagram focuses on the execution and flow of the behavior of a system instead of implementation. Activity diagram consists of activities that are made up of actions that apply to behavior modeling technology. So we have here the symbols or the notation used for activity diagram. So the first one is the initial state. So the starting stage before an activity takes place is depicted as the initial state. So it's like a start symbol in your flowcharting technique. So this is the symbol used for initial state. Next, we have the final states. So the state which the system reaches when a specific process ends is known as the final state. So this is your end. This is the symbol end for the flow charting. Next, we have the state or an activity box. So it is represented by a rectangle shape with rounded corners. So action. So basically, you will be describing the activity, the actions, the procedure inside this process box. Next, we have the decision box. It is a diamond-shaped box, same with your flowchart, which represents a decision with alternate path. It represents the flow of control. So basically, this decision box consists of a flow line which evaluates a condition to a true, false, or yes and no condition. So I have here an example of an activity diagram. So let us consider the mail processing activity for which is shown in this slide. So three activities are specified. When the mail checking process begins, user checks if mail is important or junk. So two general conditions, it could be important or is junk. So decides the flow of execution of a process. So after performing the activity, finally the process terminated at termination mode. So we have here your initial state, and then we have here your activity, which is opening an email, and you are going to determine under your decision if the mail is important or the mail is junk. In this particular diagram, we have we will determine if the opened mail is important or junk. So if it is important, we're going to proceed with the activity reading the mail. If it is not, we are going to delete the mail. And then the process will be terminated. So next, let's proceed with another type of UML diagram, which is the use case diagram. So it shows the interaction between a system and its environment. It captures the system's functionality and requirements by using actors and use cases. So use cases model the services, tasks, and function that the system needs to perform. So use cases represents high-level functionalities and how a user will handle the system. So use cases are the core concept of unified modeling language modeling. So use case consists of use cases, persons, or various things that are invoking the features called as actors and the elements that are responsible for implementing the use cases. So use case diagrams capture the dynamic behavior of a live system, and it models how an external entity interacts with the system to make it work. So use case diagrams are responsible for visualizing the external things that interact with the part of the system. So these are the symbols or notations used for use case diagrams. So we have use case. So this is used to represent high-level functionality and how the user will handle the system. So a use case represents a distinct functionality of a system, a component, a package, or a class, and is denoted by an oval shape with the name of the use case written inside the oval shape. So this one. Next, we have here an actor, which is represented by a stick figure. So it is used to this inside use case diagram. The actor is an entity that interacts with the system. A user is the best example of an actor. Say you have librarian, student, teacher. So those are some of the examples of an actor. So I have here an example of a use case diagram. So I have two actors which are named as student and teacher. So there are a total of 5 use cases that represent the specific functionality of a student management system. So each actor interacts with a particular use case. So a student actor can check attendance, timetable, as well as test marks on the application or a system. So this actor can perform only this interaction with the system even though other use cases are remaining in the system. So the student can check his or her attendance, the student can check his or her timetable, and the student may also be able to check his or her test scores. So take note that it is not necessary that each actor should interact with all the use cases, but it can happen sometimes. So the second actor, named as the teacher, can interact with all the functionalities or use cases of that system. So this actor can also update the attendance of the student and marks of the student. So these interactions of both student and teachers together sum up the entire student management application system. So basically, in this particular example, the student can also perform 3 activities. So that's why we have to apply the level of access. So the level of access of the student is only limited to checking attendance, checking the timetable, and checking the test scores. While the teacher, for example, as the main actor of the system, we perform all the use cases that we have. So the teacher can check the attendance, can check the timetable, can check the test scores, can update the attendance of the student, and can also update the test results or exam results of the student. So next we have the sequence diagram. So it shows interaction between actors and system and between system components. So it is commonly used by developers wherein they model the interaction between objects in a single use case. So they illustrate how the different parts of a system interact with each other to carry out a function. So the order in which the interactions occur when a particular use case is executed. So we have here the notations or the symbols used for the sequence diagram. So we have the lifeline notation. So a sequence diagram is made up of several of these lifeline notations that should be arranged horizontally across the top of the diagram. So no two lifeline notations should overlap each other. So they represent the different objects or parts that interact with each other in the system during the sequence. Next, we have the activation bar. So this is the box placed on the lifeline. So it is used to indicate that an object is activate or instantiated during an interaction of two objects. So the length of the rectangle indicates the duration of the object staying active. Next, we have the message arrow. So this message arrow, an arrow from the message caller to the message receiver specifies a message in a sequence diagram. So basically, this message arrow explains the sequence of operation inside the sequence diagram. Next, we have comments. So it generally permit the annotation of comments in all UML diagram types. The comment object is a rectangle with a folded over corner as shown below, and the comment can be linked to the related object with a dash line. So I have here an example of a sequence diagram. So from the given example, we will focus on the use case named create new online library account. So it is necessary to identify the objects or actors that would be involved in creating a new user account, which would be, we have actor librarian and author credentials database. So we also be needing a user credential database and email system. So once you identify the object, it is then important to write a detailed description on what the use case does or what will be performed inside the system. So from this description, you can easily figure out the interaction that would occur between the object once the use case is executed. So this can be the steps that can be performed in creating a new online library account. So the librarian basically requests the system to create a new online library account. Okay, and then the librarian then selects the library user type, and then the librarian enter the user's details, such as, for example, name or last name, first name, middle name, USN number, program or course, address or contact number. And then the user's detail are checked using the user credential database. So basically, the system will identify if there is an existing record or if there are some duplicated record inside the system. So if the new library user or if the credentials have been checked from the database or there are no duplicate entry or duplicate information inside the database, so a new library user will be created. So a summary of the new account's details are then emailed to the user. So that's how the sequence diagram works. Next, we have the class diagram, second to the last type of the UML diagram. So it shows the object classes in the system and the associations between these classes. A class is a blueprint that is used to create object, and the class defines what object can be done or can do. So it gives an overview of the software system by displaying classes, attributes, operations, and their relationships. And this diagram includes the class name, attributes, and operations in separate designated compartments. So basically, the class diagrams is also applicable for object-oriented. So if you can remember your object-oriented classes, so we are familiar with the terms classes, objects, relationships, and attributes. So these are the notations for the class diagrams. We have the class name. The name of the class appears in the first partition. The class attributes, which are shown in the second partition, the attribute type is shown after the colon. Okay, so int void. So attributes map into the member variable or data members in the code. So this is the class without signature. So we have the name, the class name, shape. The attributes are length, and operations get length or set length. Okay, so next, notations, we have the class operations or methods. Operations are shown in the third partition. So they are services, or they services the class provides. So the return type of a method is shown after the colon at the end of the method signature. The return type of method parameter are shown after the colon following the parameter's name. Operation map into the class methods in code. So we have our class name, my class name. We have 3 attributes and 3 operations. Attribute 1, 2, and 3, integer, float, circle. And we have here the methods that will be used for your class diagram. So here is an example of a class diagram. So a class extends another class. So we have document, book, and email. So consider the book class, this one, might extend to document class, which also might extend or include the email class. So the book and email classes inherit the fields and methods of the document class, but might add additional fields and methods. So this also shows the inheritance relationship in UML match up closely with inheritance in Java. So under the book class, we have title, so which is a string, and we have a method get title string. So this book class can be associated with a document, which includes author, date, and other information. And then it can also be incorporated with your email. So once, for example, that you've done searching the title of the book, the author, the date of the publication, you can email it into your user or who requested the book. And the last UML diagram that we will be discussing is the state diagram. It shows how the system reacts to internal and external events. So UML state machine diagrams can be used to model the behavior of class, a subsystem, a package, or even an entire system. It is also known as a state chart or state transition diagram. So state chart diagram provide us an efficient way to model the interactions or communication that occur within the external entities in a system. So these diagrams are used to model the event-based system, and a state of an object is controlled with the help of an event. So these are the notations of the state diagram. So same with the previous type of UML diagram that we have discussed a while ago. So we have the initial state. This is used to indicate the beginning of a state machine diagram. So the final state, the symbol is used to indicate the end of a state machine diagram. We have the diamond symbol, also known as the decision box, which contains a condition depending upon the results of an evaluated guard condition. A new path is taken for program execution. So again, the decision box consists of a flow line which evaluates to a true, false, or yes and no values, or a Boolean expression. Next, transition is a change in one state into another state which is occurred because of some event. So a transition causes a change in the state of an object. Next, we have the state box. It is a specific moment in the lifespan of an object. It is defined using some condition or a statement within the classifier body. It is used to represent any static as well as dynamic situation. So I have here a simple example of a state diagram. So this state diagram represents the user authentication process. So OTP, I have implemented here an OTP or one-time password. So this state chart diagram represents the user authentication process. There are a total of two states or processes here. The first state indicates that the OTP or one-time password has to be entered first. After that, OTP is checked in the decision box. The OTP validation, if it is correct, then only state transition will occur and the user will be validated. If the OTP is incorrect, then the transition will not take place and it will again go back to the beginning state until the user enters the correct OTP. So we have the first state here is entering the OTP, and then the system will check if the entered OTP is correct or valid. If it is valid, the user is authenticated or validated. If it is not valid or invalid or false, it will go back again to entering OTP, and then the user will be asked to enter the correct OTP. So once the correct OTP is entered, so the user will be authenticated and the program will be terminated. So this is just a simple example of a state diagram.